Sure. Okay, 4.4, factoring quadratic expressions. Oh boy, do I have a whole lot of knowledge to impart to you today, so I'll say things over and over and over again. I hope that they will eventually resonate, which means like sink into your brain so you understand them. Just know that when I say something the first time, if you didn't get it, don't freak out, because I'll say it again. I'll say it in a different way, because all of these little tricks I give you will help you so much with this stuff. It's unbelievable. So factoring quadratic expressions, what does that mean? What does factoring mean? Well, I start out with x squared plus 6x plus 8, like right there. And what I want to end up with is these two parentheses. So like step 1 is the problem I have here. Factored form is number 2 right there. Okay? So they're showing you the opposite direction now. That would be our check step. So we'll multiply things together. I used to do FOIL all the time. You'll hear teachers talk about foiling, right? Multiplying these two binomials together. This is a binomial. That's a binomial. It is a linear binomial because x is to the first power. So if we multiply together, that's not the right number. If we multiply together two linear binomials, we end up with a quadratic trinomial. Quadratic because of the 2, trinomial because there's 3 terms. Coming up in 6 weeks, you take only the most important test of your life, SAT. Anxiety just went up. Thank you, Mr. Evans, for giving me a heart attack. So what do you do to handle SAT? You take a class, right? You buy a book with double speed Algebra 2. I don't have time. I tried to do that Khan Academy thing. We just don't have time to do it at double speed Algebra 2. But you also have access to Khan Academy, so you can get in there and do anything you want with SAT, including taking a full exam. There's study skills, there's strategies in there. For me, what helped me the most on my SAT score was taking a class, and what I learned is test-taking strategies. I had the knowledge, but oftentimes on a multiple choice, I couldn't demonstrate the knowledge to the level of my understanding. That is like pure frustration right there, right? I know more than I can demonstrate on a multiple choice. Why? Because I would overthink stuff, right? I'd narrow it down to 2, overthink it, and pick the wrong one of the 2, right? I didn't trust my gut when I was your guys' age. So first thing you got to do is determine if your gut is worthy. Like, can I trust my gut? Almost always you can. And then if you can trust your gut, trust it. Go with that first instinct, right? And don't just blindly go with the first instinct. You're trying to make educated guesses, right? Like, pull into the deep, dark recesses of your mind and pull out that information you need to be able to do SAT. Okay, but the strategies for me is what helped me the most, to the point where my SAT score went up 100 points just by learning strategies, okay? That's a massive increase, almost to the point where SAT would look at it statistically, and it's not entirely possible. Like, it's very unlikely you would have an increase that much, but for me, it was just test-taking strategies. For you guys, I don't know what it is. Strategies definitely help. I'll tell you a just hilarious yet humiliating story from me. Right, happened when I took the GRE. So you take SAT to get into the undergraduate. Right, for your bachelor's degree in undergraduate, those mean the same thing. You take the SAT to get into that. To get into grad school, you take the GRE, the graduate, I don't remember what it stands for. I could make it up, and you guys would probably believe me. But honestly, I have no idea. Whatever. It's a graduate school, one of those. And I've got a just purely hilariously humiliating story about me before I took the GRE, which I will share the day before you take SAT. The reason I will share that the day before you take SAT is because if you can laugh at my own stupidity as you're taking SAT, it's going to relax you and you're going to do better, right? So I'll use my own humiliation to help all of you, right? That's the kind of guy I am right there, right? Okay, we're going to multiply these two things together. and not the FOIL way. FOIL, honestly, pisses me off. I don't like it. Because kids are like, what's the first? What's outside, inside, left? So some kids don't get it. Many of you do. What happens when you FOIL is simply this. We take that X term and we distribute into the parentheses. And then we take the second thing in the parentheses and also distribute into the parentheses. That's all FOILing is. So I don't even like that method. The method I choose is better, of course. I like doing it like this with the box method. Because everything has its own individual little square. And if I'm trying to give you guys partial credit, this is the easiest way for me to give you partial credit. So I'm not going to even multiply this one out, x times x, x squared, blah, 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 and so on. The box is better. Do the box. So we get x squared plus x times 4 is plus 4x. 2 times x plus 2x. 2 times 4 plus 8. One of the many handy parts of the box, despite everything having its own little place, you always combine like terms, lower left to upper right. Always, every single time. So if I'm multiplying these two together, I get x squared, adding the green highlight, 6x plus 8. Done. Right, so we're multiplying binomials there. We're not factoring, we're multiplying them together. This would be the check step. Once I come up with my two parentheses here and here, I want to double check that it's right. So I do the box method to make sure I end up with x squared plus 6x plus 8. Yes?
Okay, I do remember this, but remind me why I'm using 6x squared.
Because, okay, it's a good question for others because I guarantee somebody else has that same question. If I think about 2x and 4x, why isn't it 6x squared? If I have 2 pencils and 4 pencils and I add them up, I don't have 6 pencils squared, I just have 6 pencils. So when I add, don't do anything with the exponents. When you multiply, that's when you add exponents. If that's a helpful thing for you to write down, when you multiply variables, add the exponents, that's a good thing to write down. And we'll show an example as well. So when you multiply variables, we want to add exponents. I'm going to abbreviate. An example of that would be like x squared times x cubed, which would equal 2 plus 3, which equals x to the 5th. So if I'm multiplying x times x, we have an implied exponent of 1, and I add the 1s, that's why it's x squared in the box. So I add these two 1s, and I end up with x squared, like that. So that first slide is just to check our work. That's the only reason. I don't make you check your work on the homework. On a quiz, if you don't check your work, you're just dumb. Straight up. Right? Like, check, why wouldn't you check your work? Because sometimes you're so confident you get it right, and then you check and you're like, oh shit, I actually got it wrong. So do the check step, right? Because you're going to get them right. Good. All right, write those two down. So we're factoring now. So we're going from the quadratic trinomial to two linear binomials. Right? I will force you with that math verbiage to try to get your brain thinking along those lines. It will help you. That is why. So I had this German exchange student, like maybe 4 or 5 years ago, came up with this strategy, which I've taught ever since. I love when you guys come up with a strategy that I can then use to teach future generations of students. You're happy you got me my 24th year of teaching, because I've been thinking about teaching math for 24 years. I've been talking to all of you guys for 24 years. And guess what? I've gotten to be a better teacher as a result. and continue to plan on getting better and better. But, you know, it's pretty damn good now, if you ask me. This method, however, was just, the methods that are my favorite are the ones that I refer to as simple genius, right? So how do you come up with factors of 20? Some of you guys are good at doing that, others are not. So I'll show you the old school, right? I always start with 1 and 20, and I always go in numerical order, going down this left column, 2 and 10, 4 and 5. Those are the factors of 20. So if I want to come up with my two parentheses here, actually before we do that, let's do the calculator. So bust out your graphing calculator if you haven't yet. I will bust mine out. So if I want to do factors of 20, we want to get y equals, and all I'm going to do is 20 divided by x in y1. Then what I'm going to do is I'm going to hit second graph, because then we can see what table of values apply to 20 divided by x. So what are the factors of 20? 1 and 20, 2 and 10, 4 and 5. If yours is different, make sure you look at that. 20 divided by x. Did your numbers start in a different place?
Yeah, my
Okay.
at 90.
If your numbers start in a different place, hit second window. That's where you change where your table starts and start it at 0. So second window to do that. Change your table start to 0. And this means what your table goes up by, the 1 here, so make sure it goes up by 1 as well. And then hit second graph. Of course, nobody in fifth period said that. I guarantee you, like most of them had 90. Okay, so the factors of 20 are 1 and 20, right? 2 and 10, and 4 and 5. As soon as the factors go the opposite, right? I had 4 and 5 here, and now it goes 5 and 4. That's when you're done with the factors. So 20 is not as hard, right? But we're going to do a problem in a minute that's 72. So most of you can't rattle off factors to 72, like 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, 8 and 9. Like most of you can't do that, right? I'm a math teacher. I've been doing this crap for 24 years, and I'm good at mental math, so I can do that, right? If you can do that too, fantastic. It makes your life easier. But if you can't, we got a backup plan. That's the important part. Okay, so if I look at this, I want to think of numbers that multiply to 20 and numbers that add to 9. So add to the B term, multiply to the C term. Actually, we'll just abbreviate. So what multiplies to 20 and adds to 9? Tell me. 4 and 5. So if I do 4 plus 5, I get 9. So my two parentheses, it's joyously easy, is x plus 4 and x plus 5. I think my 5 had a little issue here. So just to prove to you that that works, I'll just do the box, and I won't do the box again. It's just helpful to see, I think, right away at the beginning. So here I have x plus 5. We always combine like terms, up, lower left, upper right. 5 times x plus 5x. It's helpful to put the plus just because then you know to add. Like, make it easy on your brain. So we get x squared, combining like terms, plus 9x. Plus 9x plus 1c. Okay. So this is the easiest problem. The reason why it's the easiest problem is because both, and this is part of all this thing I'll say like 8,000 times, when the sign on B is positive and the sign on C is positive, both of these signs in the parentheses are positive. So when C is positive, the signs are the same. If B is positive, as it is here, both signs are positive. So if I have the same problem, C is positive and it were a -9 instead of a +9, the change in the answers would be -4 and -5 here. Okay? Again, I will be saying all of this like 8 million times, so don't freak out. When C is negative, as it is in this problem, my signs are going to be 1 plus and 1 minus in the parentheses. I'll say it like the signs are opposite in the parentheses. So I know I have x plus something and x minus something. So many of you guys are hesitant to do this strategy, and this is one of the best strategies there is. Now, raise your hand, don't say it out loud, if you know what goes in this box in the parentheses. Good. I'm just curious. We got one person who knows so far. Anybody else? You can put your hand down. Anybody else know what two numbers go in the parentheses? So one person, not a single person in fifth period knew. Okay, that's the second person. So 2 people out of like 55 have known what the answer is. So, hello, we need a backup plan, right? So I'm going to put 72 divided by x in the y equals, just like that. And then I'm going to go second graph. You don't have to put -72. We'll worry about the negative later. Just put the number. So when I look at this thing, there's my list of factors. Let's actually copy it. So here's my little list of factors I want to consider. So because C is negative, I want to subtract the T factors. So my signs will be opposite, and I want to subtract. So I'm looking for the difference of the factors. So I'm looking at that list of factors, and I'm thinking to myself, what 2 factors can I subtract and get positive 14? Raise your hand once you know. What 2 factors can I subtract and get positive 14? Just waiting for the hands to creep up. I'm patient. I'm still waiting. What 2 numbers do you subtract and get positive 14? Every single one of you can do that. Okay, excellent. So the answer, now how the hell do I know if it's positive 14 and -4? Or 18, I did mean 18, thank you. Trying to be all tricky here. So do I know if the 4 goes here, or the 18 goes here, or the 18 goes here, or the 4 goes here? Yes?
No, not like that.
Which one, Sam? It's got to be positive 18 minus 4. So let's just think about that, and then I'm going to erase this. So it's got to be 18, because what's 18 minus 4? Positive 14. Right? It can't be 4 minus 18, because then we get negative 14. So that's why it's got to be positive 18, -4. So I'm going to erase this, because this is inherently confusing. And then I'll take your question, maybe. So positive 14, and I really want to erase 14. I don't know what my problem is. Positive 18, yay. All right, so 18 minus 4 is 14. 18 times -4 is -72. Question, Maggie.
So on that, what I meant by the pattern is if you put the in parentheses x minus 4 first,
Right.
or the parentheses, that's what I meant.
So what Maggie's asking, which I'll show you here, especially once I erase that. So what Maggie's asking, given this problem up above, doesn't matter if we say this or we say this. Is either one correct? Raise your hand if you think it doesn't matter. Raise your hand if you think it does not matter. So here's why it doesn't matter. Related problem, but same mathematical property. What do both those equal? 6. Both of these are the same thing. This is called the commutative. What a great thing to write down. You might see that in 6 weeks on SAT. So what the commutative means, if it doesn't make sense in your brain to look at these two, look at this one and this one. That, I think it's just easier to understand. So if you think about those of you in person that you drove from home to school, you're commuting. If you drive from school to home, same distance, right? Same concept, related, we're adding there, but related concept. Multiplication, you can switch the order, it doesn't matter. Same thing works for addition. You can do 2 plus 3 is 5, 3 plus 2 is still 5. Okay, so that's a commutative. And I remember if I'm thinking about commuting to from home to school and vice versa. All right, that's the second slide. It goes faster as time goes by, but there's a lot of knowledge to impart at the beginning here. So let's look at C here. So write C down. The difference of C is we have to factor out a greatest common factor, GCF. You always, every single one of these problems you do, want to look for a greatest common factor. So what is the greatest common factor here on C that we can divide out? Oh, we have a little, yes, we want to get rid of the negative. So I look for that GCF. I want to get rid of that negative x squared, right? Many times it'll be a number like 2 or 4 to factor out. This one's just a negative. Don't try to factor these things with negative x squared. It sucks. Okay? It's going to make you unhappy. You can do it. It's possible. It'll just wreck your brain. I don't even like doing it. I've done like 8 million of these things. So all I do in the parentheses is switch every sign. That's what dividing by -1 does. So I have the negative in front, and then I switch every sign. Switch the sign of x squared, the x term, and the number. Now, we have a positive c term and a negative b term. When you have a positive c term and negative b term, the signs in the parentheses are always both negative. So positive c, we have the same sign. If we have a positive c, both signs would be positive here. Because we have a negative b, both signs are negative. If I have a positive c, the signs are the same. If b is negative, they're both negative. Okay? If I have a I'll say it again, right? I say these things like 8 million times, like I said. If I have a positive c and a negative b, both signs are negative. You want me to write that? Yeah. So if I have a positive c, and eventually this will be automatic in your brain. So positive c and negative b, those signs are negative.
So if the c is negative, that means both the signs are negative.
As long as c is positive, yes.
And then
You have to have both, right? Because I could have a negative b and a negative c,
that means one of them.
then 1's plus 1's minus. So when c is negative, the signs are opposite. So that's a good way to think about it as well. So that's idea number 1. Idea number 2 is just if c is negative, your signs are opposite. That's the quickest way to say it. And if that doesn't make sense in your brain, say like the signs are different, you have 1 plus 1 minus, whatever. I say signs are opposite. That makes sense for my brain. And we'll talk about every possibility. If they're both plus, B and C, that's the easy one. They're both plus in the parentheses. Okay? If it's a positive C, negative B, both signs are negative. If it's a negative C, the signs are opposite. And then we'll talk about the B term in a minute. Just not yet. Okay, so up top here, back to this guy. So what factors of 12 add to 13? 1 and 12. That's often the easiest one to get, yet the hardest because it's easy. One of those kind of things. So 1 and 12, and I'm done. So when the B term's bigger, it's always got to be 1 and whatever the number is. I always like making these things up in my head because they help me. And sometimes I'll give you like way too much of that. So if it ends up being way too much, just stop listening to my little nonsense. But it'll help you. This is a good lesson to listen to again as well on the video. If there's part of it you're like, what? Then go back and listen to just that example. It'll help you understand. Try this one on your own. Both positives. Make your parentheses. You're not both pluses in these parentheses. You can do 40 divided by x in the y equals to your graphing calculator if you don't know what it is. Sometimes you just see it and you're like, yeah, I got it done. Right? I can look at that and I know the answer. You got it, right, Sam? I'm putting pressure on Sam. That's okay. She can handle it. She's strong. She didn't get it right away is what that means. It's okay. You're going to get it and you're going to be like, damn,
I got it, and then as soon as you said that you could look at it and see it, I got it.
yeah. Now you got it, right? So the moment is like, don't feel stupid when you don't get it right away. Just be like, I got it. And you're like, damn it, how did I get that sooner, right? Is that how you feel? Yeah, because I called on you? Yeah. I appreciate the honesty. And I try to do that to you guys. I will, like, put that quick pressure on you to see how you respond. Because in life, you'll get that quick pressure response, right? Yeah. Factors of 40. I like old school as well. Sometimes I'll do this.
Factors of 40. First instinct was 4 and 10. I'm like, wait, those add together to 14.
Yeah, good. So I think it's good to be able to see the factors. It makes more sense, especially when you have 1 minus 1 plus. Being able to see the factors helps. So then, bam, I'm done. X plus 4, X plus 10. Right? What multiplies to 40, so what multiplies to C. That's another good thing if you need to write down, is what multiplies to C. And adds to D. All things you can write down if they help you. Like I think looking back at your notes as you do this homework, you're like, oh yeah, that's what multiplies to C and adds to D. Like that stuff will help you figure it out. So if you need that, write it. If you don't have to write it. That's fine. Do this one on your own. I'm saying nothing. Think about your signs. I'll talk about it after. Malfoy looks like he's ready for a date today. That's a guy you want to keep your daughter away from. Do the virtual hand raise once you're done at home so I know, please. And I'll know in person, like always. And then you can have a little challenge to see who does the thing first, because that's fun. but don't get it wrong. Like, put pressure, time pressure on yourself, but get it right. Like, that's the definition of SAT. Time pressure, but get it right. Realize, you guys, SAT, and I'll start to talk about it more and more. So if it creates anxiety for you, figure out how to deal with that anxiety, right? I've got like 8 million coping mechanisms to help you if you need, but you got to cope with that anxiety because it's crazy. So the way they design SAT math, especially for a regular Algebra 2 student, they design it to get increasingly harder as you go through it. Okay, so there'll be like the last 5 to 10 questions. It's just the average Algebra 2, regular Algebra 2 student will have no idea how to do. Don't worry about those questions. So let's say you've got 30 questions on SAT math. The last 10 you don't know how to do. So 10 out of 30 you don't know how to do. You should think in your head, oh shit, I already have a 67. 2 out of 3, 2 divided by 3.6 repeating, you have a 67%. That's not how SAT works. What's super important is that those first like half of the SAT questions in math, you've got to get those ones right. Those are the ones you should get right. So if you waste a lot of time on those last 10 questions and you miss a couple of the easier ones, your score will go down massively, right? If you focus on the earlier questions to make sure you get every single one you can get right, your score will be better. You can read like that exact description in any SAT manual, and if it doesn't have it, throw the manual away because it's a piece of garbage. All right, so this one, factors to 30, we'll just go through the process so you can see. So C is positive, I know, and B is negative. So that means I know both signs in the parentheses are negative. I'm looking for the sum of these two factors. -5 and -6 is -11. Done. Raise your hand if you got it right. Actual hand at home. Oh, you're also smart. Well done. Of course, it's the one kid who doesn't have her hand up. I just made you feel stupid, but never mind them. Okay, write these two down. Little different wrinkle now. Kind of 3 big concepts we're teaching. This is the second of the 3. We're looking for a greatest common factor. That's what they're introducing here, finding common factors. They're talking about your friend and mine, the old GCF. Greatest common factor. So if I look at 6n squared plus 9n, what's the biggest number? You can show me with your fingers. I can divide out of both 6 and 9. You good? As soon as I say good, put it down so people don't cheat, because they always cheat. Biggest number I can divide out of 6 and 9. Anybody not know? Okay, put your hands down. Raise your hand if you don't know. Like you're looking at that going, what the hell happened? You're liars. I know there's somebody out there. There was one kid last period who was like, I got no clue. Here's how you get a clue. So if I write 6 and 9, because you might get one of these where you get stuck, so you need a backup plan, right? And I write factors of 6, and I write factors of 9. The biggest number I can divide into both 6 and 9 is 3. So that's what I can divide out of both 6 and 9. That's your backup line in case it goes horribly wrong. If I give you gigantic numbers like 1,024 and 480, most of you wouldn't know you could divide 16 into both of those. Right? That's like math feature weirdness I can do in my head. So I can divide a 3 out. Now realize with the n's, here's the concept with the n's. N squared is the same thing as 2 n's multiplied together. This one just has an n. So what's the most amount of n's? What's the greatest common factor of the n's? Just one of the n's is the greatest common factor. Not 3, like somebody said in Pearson, to remain nameless. You won't say who it is, Maggie? Oh, sorry, that was an inside thought. So 3n in front, and then all I do for what's in the parentheses is I just reduce the two fractions. So if I divide, I'm going to write the 6 up here, so 6n like that, just to illustrate the point. 6 divided by 3 is 2, and I cancel one of the n's up top with the n on the bottom, and I have one n left, so that's why I have 2n. When I divide out 9n divided by 3n, 9 divided by 3 is positive 3, and the n's cancel. It's good I know you, Maggie, so I don't offend you, you know? That was kind of funny, though, you gotta admit, right? Okay, what's the greatest common factor of the bottom one? Show me with your hand at home or in person, either way, good. Put it down, good. Good. Good, good. Show me at home. Give me the quick flash. Yep. Good. Oh, that's very sly, and I like that move. Hannah gave me one of these. She was like, it was good. So I look at, right, so if you're not good at doing this, I always have strategies, right? So I think what are factors of 4? I have 1 and 4 or 2 and 2. So I look, every one of these 3 numbers is even, so I know 2 works, but I could also try 4. I look at 20, does 4 divide into 20? Yeah. Does 4 divide into 56? Yes, it does. Right, so here's what I think of dividing 4 into 56. I do it like this, honestly. 4 divides into 5 one time with 1 left over. 4 divides into 16 4 times, so 4 divides into 56. You could think of it like this too, old school, like you're in 4th grade again. Right, so 4 divides into 5 one time, 1 left over. 4 divides into 16 4 times. We're going to do that later in the year with a linear binomial divided into a quadratic trinomial, long division of polynomials.
Has it not become a talk about that?
Yeah, so one of those things where, like, sometimes the kids that struggle the most, like, that's the thing they get, and it's just miserable. But sometimes the weird, harder stuff, some people just totally get. I don't know why. So I can divide a 4 out of each part. So I have 4 parentheses, and then what do I have left? I have x squared plus 5x minus 14. So c is negative. My signs are opposite. So I'm thinking of factors of 14 that are 5 apart. Meaning when I subtract the 2 factors, I get positive 5.
Why are we doing that for this question, but we didn't for the other one?
So, perfect question asked. Sophia, why are we doing this for this question, and we didn't for the one above? So the one above, let me erase some of this stuff so it's a little more, not so much, that's fair. So that is a quadratic binomial. You can only factor into 2 parentheses if you have a trinomial. So because this is a binomial, 1, 2 terms binomial, that's why you can't factor into the 2 parentheses. It's a good question. Okay. What's the answer? Plus what, minus what? Tell me, Amanda. Yeah, you got it. Plus 7 minus 2. Good. Right, so if you get confused which one's positive, which one's negative, this is the last little strategy I have to share for you. So C is negative. That's the beginning of this little helpful hint. If C is negative, so if C is negative and B is positive, and the vice versa works as well, the bigger factor is positive. And I'll show you what I mean by that, because it needs explanation. Some of you may get it right away. So if C is negative and B is positive, the bigger factor is positive. So you might look at that later and be like, what the hell is he talking about? Oh my God, that makes no sense. So I have two factors. I have 7 and 2. So this says if C is negative, as it is, and B is positive, as it is, the bigger factor, 7, is positive, which means the smaller factor is negative. 7 minus 2 is positive 5. If I instead did 2 minus 7, so this one would give me positive 5, this one would give me negative 5. So that's why the 7 has to be positive. So if I see that negative C, I get my two factors, I look at B, it's positive, bam, bigger one's positive, done with the problem. Okay? That'll take more practice to get that strategy ingrained, but this is a great backup plan. Let's say you have no idea, you read that, you're like, I don't know what the hell he's talking about. I know the factors of 14 that are 5 apart are 7 and 2. Then all I do is this, 7 minus 2, 2 minus 7, and I figure out which one gives me the B, just like I did, right? So it's got to be that one. So even if you don't get that strategy, just like switch the order of the factors, subtract them, and you're going to get the correct answer eventually. Maybe. It's possible. Try this one on your own. Biggest numbers to divide. Most variables you can take out of each. With the little tricks thrown in because it's mildly weird. So once we're all back in person after spring break, we've got a couple people that are staying home, I think, still, even after spring break. If that's you, no worries, but all the people that will be here will be taking the paper pencil version of the quizzes. And then at home, you'll all have to create it in such a way where you can only see one problem at a time and torture you in creative ways like that. But in person, you'll just get the whole quiz. So if you like to jump around, look at different problems, you'll have that availability. At home, you'll still only be able to see one question at a time. Okay, so if I look at this one, I think the biggest number I can divide out of each is 7. I take that 7, I write it in front of the parentheses. The 7's cancel. I have n squared left. 21 divided by 7 is 3, and I'm done. How many people got it right? Good, at home. Good, nice. So realize, you guys, one of the favorite little math, whoever the math nerds are who write these books, sometimes this thing in the middle here, you can still factor. So don't think just because you divided something out, you're done. Definitely look at what's left in the parentheses to determine if you can still factor it or not. Question? Good. Alex? How did I get this? So because this 21 did not have an n, that's why I couldn't factor an n out, right? If that one had an n, then I could have factored a 7n out like that. But this one does not have the n. So I just look at 7 and 21. The only factors of 7 are 1 and 7. Factors of 21 are 1 and 21 and 3 and 7. What's the biggest number I can divide out? 7. Right, so that's what I divided out right there. Okay, what's 7 divided by 7? What's left? N squared. That's why. Okay? And then 21 divided by 7, you know that's 3. That's the easy part, right? Okay. Try this one. There is a GTF. It is not free.
I know what.
You better know what it is. Huh. So as I said, I think I said at the beginning of class, I don't know if everybody was there, so I'll say it again. I do have all of your quizzes graded if you're sitting at home. I'm going to wait until I see you tomorrow to hand them back. So you're not going to know what you get until I hand them back because I'm evil. Just so you know. Okay? Yeah, I thought you'd like that. But I took time to make comments. I did it neatly. It wasn't just like, sometimes I'll grade stuff so fast you'll hardly be able to read what I write. But I wanted you to see the feedback I gave you. I gave you feedback in such a way that I hope the feedback I gave you will help you to do better on future quizzes. Like I gave you specific feedback. To include like 19% on your quiz, please see me. Right? Because some of you got that. You know who you are. The ones that aren't trying. So, if you get that, please see me on your quiz. Do it. Come at access time. See me after class. Pull me into the hall and talk to me about how you're going to do better in my class. Because you will be better. I will make you. You have no choice. I will educate you. It's rare when I get a kid who just gives me the giant middle finger when I say that. Almost every single one of you wants to learn. Just all your bullshit gets in the way sometimes, right? Prevents you from learning. How many people factored out the 9, got to the parentheses, and then had a little struggle bus moment? Okay, because that's why I put this one on there, because I wanted you to have that. It looks so simple. You're like, how can't I get this? So we're going to talk about this so we make sure. Right before I even begin, I'm looking for a GTF. There is one. It's 9. I continue to look. I'm not doing anything yet. I'm just thinking about things because I'm trying to orient my mind here. I look at the C term. It's negative. So I know I have to have 1 plus 1 minus. I look at the B term. It's positive. So I know the bigger of the 2 factors is going to be positive. That's just me like setting the stage for my own brain. And then here's the process. So we're going to divide that 9 out. 9 goes in front. What I have left is x squared plus, I'm going to write the 1, you don't have to, minus 2. So, like, that's so easy to factor. How could you factor it? Of course, like, it's so easy, right? So, the only factors of 2 are 1 and 2. Again, having the visual, if you get stuck, write the factors down so you can look at them. You'll get it right. I know because my B term is positive, my bigger factor has to be positive, which means my smaller factor has to be negative, right? So what is the final answer here? Simply that, right? So writing those factors down, if you get stuck, will help you. And just like, I want to be that annoying little voice in your head that's like, oh yeah, I haven't said to do this, right? I'm trying to brainwash you in a positive way so you can learn math. That's my game here, right? So it's not that bad. But sometimes the easy ones, you're just like, what the hell? Doesn't make sense. Okay. Third main topic of the day. So we did the little factoring binomials, right? Like the 6n squared plus 9, factoring that kind. We also did the factoring of trinomials where we have the 2 parentheses. This one, we'll hear like an audible groan, so listen at home. This one is your favorite method and mine. Indian method. Okay, it's not from a Native American, not that kind of Indian. It is from a person from India who created this method. What we're going to do is I'm going to teach 2 examples, no questions allowed. When I teach like a step-intensive kind of process, sometimes we get bogged down in the questions and then nobody knows what the hell's going on. So I'm going to do 2 of these in their entirety, yapping at you along the way, teaching you the method. Then we're going to do a third one. You can ask all the questions you want. Okay, Indian method. First thing we do is we start with the cross. Top of the cross, we have A times C. Bottom of the cross, we have B. So we're thinking of the A times C, the numbers that in front of the x squared and the number at the end. That's what A times C means. In this problem, A is 2, C is 12, 2 times 12, 24. The B term goes on the bottom, the B term is 11. We want what multiplies to the top and what adds to the bottom. Remember, in the graphing calculator, if you're not good at coming up with factors of 24, you can always do 24 divided by x. I like writing them because I like you guys to be able to see them as well. So I'm just going to write the factors of 24 in the middle here. So I have 1 and 24, 2 and 12, 3 and 8, and 4 and 6. I want to think of numbers that multiply to 24 and add to 11. The bonus of this example is both B and C are positive, meaning we're going to add the 2 factors. Right, so I taught you all those little tricks, now I'm emphasizing those little tricks. So which ones add to 11? 3 plus 8 is 11, so that's what goes on the side of the cross, 3 and 8. So we just did the cross, A times C up top, B on the bottom, what multiplies to the top, what adds to the bottom. Next step, we take the A term, including the x, we write it as the numerator of 2 fractions. So this is where your highlighting in multiple colors will help you. So we take that 2x squared, the blue highlight, and we write it up top. Numerator of 2 fractions, here and here. We take the sides of the cross, the 3 and the 8, and we write those below each of the A terms. So this is helpful because you go back and look and you'd be like, where the hell did that 3 come from? Oh yeah, the green highlight over there. Where the hell did that 8 come from? Oh yeah, right here. What you have to remember now, and you just got to remember this, it's just part of the method, you have to remember to add an x down there. So with this Indian method, you've got these 2 fractions. When we reduce fraction number 1, that's our first parenthesis. When we reduce fraction number 2, that's our second parenthesis. The only thing I can reduce out of that first fraction, I'm going to rewrite this as 2 times x times x. Normally I won't do that, but I just want to make sure people get it. 2 and 3 do not reduce. Let's say you didn't know that, because you'll get bigger numbers that may or may not, right? Like if I had 17 and 51, most of you don't know that reduces to 1/3. So it's not a bad idea to double check. You're not going to double check 2 and 3, but I'm just making the point. So you do 2 divided by 3, math enter, enter. If it doesn't reduce, you end up with the same fraction. So that tells you it does not reduce. Just a little trick. So, but the x cancels with an x below, right? So what is my parenthesis here? My parenthesis is 2x plus 3. First parenthesis. Second fraction, 2 divided by 8 reduces to 1/4. Just to show you on the calculator again, 2 divided by 8, math, enter, enter, reduces to 1/4. So it's all, if you get stuck, right, you can do these techniques. So instead of canceling like I did up here with the x below, what I can do, same method, is just cancel that square and the x below. So what's my second parenthesis? My second parenthesis is just 97, right? X plus 4. All right, so what do I have left in this whole mess of stuff that I've canceled and reduced? I have X plus 4 left. That is the Indian method. So just to give you a sense of how evil I am, because I like to just tell you straight up, right? So I always will get some kid who's resistant to this Indian method. They're like, kiss my ass, Evans, I'm not doing this Indian method. Like, not a chance. What I do is I will literally, and I enjoy it in a make your life difficult kind of way. If you know the Indian method, the problem will be no problem for you. You'll get it. You'll laugh. You'll think about the one kid who fights me on the Indian method and just laugh at them as you watch them try like 8,000 different parentheses. I will create one that's so hard to factor if you try to do it in your head. I literally had this one kid who tried 30 different, I counted because it was so impressive, 30 different combinations of numbers in the parentheses. They never got it right. I gave him 2 out of 4 points because I'm a nice guy, right? But next to that -2, I wrote, haha, should have done the Indian method. And like looked at the kid's face as he flipped through his test to look at that page, and I was like, in your face, I told you I'd get you. So moral of the story, please learn the Indian method. I enjoy figuring it out by hand. I never do the Indian method. I would be that kid that took the challenge from the teacher, being like, I'll figure it out, damn it. But don't be that kid. Don't be like me. Be smart, right? So there's the Indian method. Just quick little recap to help solidify this thing in your head. I'll teach one more example, no questions. Last example, all the questions you want. First thing we do is make the cross. I've written steps for this. There's so many steps it doesn't really work. It's just, you'll get the process down. Make the cross. 8 times C, 12 times 2, 24. Right? 12, or 2 times 12, 24. B term in the bottom. What multiplies to the top, what adds to the bottom. I look at my list of factors here. 3 plus 8 is 11. That's why we have the 3 and the 8 on the sides of the cross. Next thing I do, I take my A term, the blue highlight, I write it as the numerator of 2 fractions. Then I take the green highlight, the 3 and the 8, I write it as the denominator of 2 fractions. And you just got to remember to add that x. When I reduce my first fraction, I can just cancel the square and the x, and then I write what's left, 2x plus 3, that's my first parenthesis. I reduce my second, 2 divided by 8 reduces to 1 over 4, so what do I have left? X plus 4, x plus 4. Boom, boom, done. To prove to you it works, I'm going to do a rapid-fire box method here. You don't have to do this. On a quiz, you better do it. I get 2x squared plus 3x. 2x times 4 is plus 8x. 4 times 3 is 12. Combining like terms in lower left to upper right. I would get 2x squared plus 11x plus 12. Right, that proves to you it works. So, again, I will never make you do that. That's totally for your benefit. That means like half of you won't do that, and that means half of you are not that smart. Okay? On a quiz, for sure, double check. Why wouldn't you? Like, that cost me a lot of my life. Just do it. All 20 seconds, right. That's 20 seconds you'll never get back, but you'll be smarter, so that's good. All right, write this one down. Indian method, no questions. First thing you do is make the cross. A times C up top, B on the bottom. A is 4, C is -3. 4 times -3 is -12. My B term is -4. My B term goes on the bottom. In the calculator, you could do 12 divided by x, second graph to see the table. I like writing the factors, so I always just write them. Because it helps you guys to look at the factors. I'm looking at those factors saying, which one can I subtract and get 4? 2 and 6 I can subtract and get 4. So I just got to think, is it 2 minus 6? Or is it 6 minus 2 to get me negative 4? 2 minus 6 is negative 4. 6 minus 2 is positive 4. That one's not right. This one is the correct. So I have positive 2 and negative 6. The order doesn't matter there either. I could write negative 6 first and positive 2 second. Totally doesn't matter. Next step, I take my a term, 4x squared, and write it as the numerator of 2 fractions. This is like taking that a term and writing it as the numerator. I would say it's probably the most common mistake students make in doing this process. So just be aware of that. Look at the pink highlight, it'll help you understand. So I take the 2 and the negative 6, and I write it below my 2 a terms, adding the x. Don't forget to add the x. Then I just have to reduce my 2 fractions. Now, when the numerator is bigger, as it is in this first fraction here, don't just divide, because then it's like what's left in the bottom. I still think of this as reducing. So 4 and 2, I can divide 2 into both. 4 divided by 2 is 2. 2 divided by 2 is 1. Then I cancel the squared and the x always. Cancel squared and x. 4 divided by negative 6 reduces to 2 and negative 3. So my parentheses are 2x at the beginning plus 1 at the end. Next one, I get 2x at the beginning and minus 3 at the end. Okay, so that's the whole Indian method. Any questions? Yeah. Which one? The first one or the second one? First one. 4 and 2, we could reduce to 2 and 1. So that's where I got the 2x right here. You good? Okay. Other questions?
Okay. How do you know if you use the Indian method?
Great question. Question was, if you didn't hear it at home, how do you know when to use the Indian method? First thing I do is I look at the original problem. The first thing I'm always looking for is a GCF. 4 and 4 are good on the first 2 terms, but that 3 screws it all up, so there is no GCF. So because I have a number in front of the x squared that I cannot factor out, I have to do the Indian method.
So you can't find very common method.
No GCF, number in front, Indian method. That's a good little summary to write right there. So no GCF, number in front, of x squared, your friend of mine, the Indian method. Good question, maybe. That'll definitely help people. Good, so always look for that greatest common factor first. You know I'm going to put that on your quiz. 100%, I will put GCF on there. I'll put a GCF on there that'll like make you think for a second, kind of GCF on there. So just know that's how I'm thinking about this stuff. I love these kind of problems. It's one of my favorite things in Algebra 2. It is so important for you guys to learn this and understand it on a deep level, because you'll be factoring from now until you're done taking math. For some of you, that's longer than others. Indian method, try it on your own, the whole damn thing. I'll start in like 3 or 4 minutes doing it in case you get stuck along the way. Hopefully that'll help break you out of it. I'm not going to talk as I write it down unless you guys want me to, but I just want you to have the ability to be able to try it on your own. Good luck. Just thinking out loud here, I wonder how many of you set the stage in your head to think about the C positive or negative, look at the B as B positive or negative, and then know what the signs are in the parentheses before you begin. Always a good idea to set that stage in your brain. Like building the frame for a house. After we're done with this, we'll be done with the lesson. I'm going to talk to you about a challenge problem that you're going to create 2 of these, and then you get those extra credit points. We haven't done one of those in a long time, so I kind of forgot about it, to be honest. But challenge problems can make the difference between your 89.4 and your 89.5. I'm a math teacher. I round. I have other math teachers in my department that do not round. I yell at them and call them stupid, because it's stupid if you don't round, especially as a math teacher. But we've got like half the department that refuses to round grades. I'm like, what the hell is wrong with you? Okay, do the virtual hand raise thing once you're done at home, just so I know. Thank you. Okay, so if you got stuck, I'm going to start doing it. Try to figure it out still, but I'm going to do it as well. So hopefully that'll help you. Ooh. Raise your hand if you got it right. Nice. Okay, if you got it wrong, Jerry, what'd you do?
No, I just to the fashion part and
You just hadn't finished yet? Okay. Anybody at home feel comfortable admitting if they had a struggle, what it was? Might help somebody else. Nobody. Okay, don't forget to take your virtual hand raising down, Maggie. Okay, what was your struggle? Because sometimes breaking through that struggle is important.
I couldn't figure out the one really tripped me up because I was like, oh, it's one X. So I put X on X, and I was like, that doesn't make any sense.
That's good. So the one I put in the square confused some students. I guarantee you it was others other than Maggie. Right, 4 divided by 4 is 1 over 1. So she thought maybe it was x over x, but she just forgot to cancel here. Right, so the 1 and 1 is just 1x plus 1. I don't care if you put the 1 in front of the x or not. Either way is fine by me. Okay, here's your challenge. Challenge problem scenario. I'm going to give you an example of 2 different kind of problems. So I want you to create 2 quadratic trinomials that you factor, and this happens. Three, thank you. I guess as I was writing that, I was like, wait a minute, I just wrote the wrong number. That's 3 here. Right, so write 2 quadratics where factors, you have the same numbers in the parentheses and the signs are opposite. That's your challenge problem. I'm not writing it in the homework. I'm telling you verbally, create 2 quadratic trinomials where you have the same numbers in the parentheses, same letters, and all the changes is 1 plus 1 minus, switches order. It's really easy to do depending how you think about it. So think about it in the easiest possible way. I'm not telling you what that easy way is. See if you can figure out what the easy way is. No help. Somebody in person raised their hand. I'm like, no, it's a challenge problem. You'll figure it out. That's part of the challenge. And they were just like, no, that's not okay. All right, your homework is page 221. 221, 15 through 45 odd, right there. Okay? It's 16 problems. Some of them you'll do like instantly, so it's a couple more problems, but I think it's totally fine, the amount. And it's good to practice. We will spend another day on this tomorrow. It'll essentially be a work day. We'll answer some questions at the beginning and then do more of this kind of stuff. Super, super important that you get this stuff down cold. Okay? I don't really care if you guys peace out right now at home. No, wait, is that right? Okay, yeah, we're good. Because we only have 5 minutes left. I filled your head with a lot of knowledge. So if you're good, if you're fried, fantastic, peace out. Have a good day. If you're not, work on your homework. Yeah.
Do you have access time today?
I do have access time today.